was really drawn to sort of the concept of isomorphic JavaScript when I first heard Spike Brim talk at JSConf last year, and when Airbnb sort of open sourced Render, which is a way of running backbone applications on the server. I think that for a pretty long time, this concept of like isomorphic has sort of been seen as like the holy grail of JavaScript. Being able to write applications once and have it, be able to have a great, single-page application and then have it not really have to worry about server-side rendering as well, for it just to work. So I started getting interested into it. The word isomorphic kind of like drew me to it. It's a pretty sexy word, and I think it's but really all it is shared code. It's code that runs in both the client and the server. And I think there's a spectrum that goes anywhere from like shared mustache templates all the way up to something like Meteor, where you have a client database access. So I started experimenting with isomorphic stuff, and I made this. I made an open source repository. I got the name isomorphic on npm, which I thought was pretty cool. And so then I started really noticing it sort of like as a trend and sort of a direction of front end in general. Backbone had render, React had render to string, and then Ember has recently introduced fast boot. So it seems to be sort of a definite trend in sort of front end engineering in general. But now, the word isomorphic isn't really cool anymore, but, whatever. So React really made isomorphic JavaScript, extremely easy. If any of you guys have ever tried using render, it's really extremely complicated. Pulling up like a render demo app, they have to have like a jQuery run on the server. There's a lot of sort of things in order to get a render app working that I think are a little bit confusing, where React sort of made it extremely easy because really all you have to do is go render to string and it just works. So I sent around this GitHub repository that I created. I put a link into it in the meetup group if you want to take a look. But if you go under the starter section and you look at the server.js, 1 second. You can see that this file is less than 100 lines, and it does really everything you need to do in order to get sort of like a full isomorphic application running with React. It runs your front end, Node server. It also this takes care of like your Webpack server to like handle building your assets. It renders out your HTML here. It calls React render to string, and then it hooks up and then it gets React running in the client for you. So I think this is like extremely digestible in the sense of less than 100 lines, and it's really amazing. I think like all that React is able to do in such like a simple way. If you run this demo app, all it does is export this hi from React, and then if you click it, it fires an alert to show that it rendered both in the client and the server, and events are hooked up, etc. Yep.
Is there
Yeah. Do you rub the Wi-Fi real quick?
Yeah. I'll work on it. Okay. Thanks.
Yep.
Yeah, because once we're in an interruption, could you share your screen, please, on the Hangout?
Yeah. 1 second.
I think it's the green arrow. Oh, there you go.
That's cool. So yeah, React made it extremely easy, basically. And so when you're creating an isomorphic application with React, it's actually a pretty nice application workflow. You can sort of treat Node as like a UI layer. Your entire your database doesn't have to be in Node, etc. You can just sort of, and I link here to an article by Nicholas Zakas where he sort of describes this Node UI layer, where you have your node, your front end server running, and then it sort of basically just does a request to like a back end API server, and so then it handles like rendering that to a client. With React, there's really not too many abstractions. So an abstraction is just a way of like writing code that works like in both the client and server. So for example, being able to like require something in Node is typically different than a client. So something like Webpack sort of takes care of that and makes it totally transparent to you. There's very few abstractions in sort of in an isomorphic workflow with React. There's a couple of challenges though when you're dealing with Node compared to just React, and one of those things is like being careful with context. So for example, it's important to keep in mind that when you're working with Node like can share variables across concurrent requests. So if you want to like keep track of user authentication, it can be dangerous to like say to use like a local variable cache in order, even though that would like work okay in the client. Doing that on the server would be dangerous because then those that could be mixed up across concurrent requests. So with Node, you should definitely use like bind things to like the request response, in order to have keep a context there. There's certain like open source repositories like React Router work really nice, and they also work with an isomorphic context as well. So like you can use React Router both on the client and the server. I think the overall like workflow for like the ability to create an isomorphic flow is really easy. So what makes this like really cool? And so I think the biggest sort of benefit to React's isomorphic concept is their ability to have what's called like smart server-side rendering. And I think this really separates it from like standard mustache rendering, where you would like render out just a regular mustache template, and then say you would like pick that up in Backbone with like even if you have shared templates, your server and your client, there's still like a pretty big disconnect between them. And so with smart server-side rendering, like what React is able to do is it able to be able to have like you basically send your markup through this render to string method, which attaches like a checksum onto that markup, and then when your client picks it up, it sends the same data hash through the regular render method. It checks to make sure that it's in sync with what came down from the server, which is pretty simple. It's just like a regular checksum, and then it follows like a base 10 numbering pattern. So there's not really any magic happening there. And if all that's in sync, then all it has to do is one lookup on your document level, and then one single event binding, and then it's good to go. So the way that this is possible is because of like the virtual DOM in the synthetic event system in React, where your front end client has like a full knowledge of like the DOM without having to look at it. So if you compare this to sort of like how a regular Backbone application would work, or how standard like jQuery, spaghetti code would work, is those are really like more low-level type systems where in order to get like an every client application needs an understanding of the DOM, but in order to get that, jQuery, like as soon as that DOM ready event fires, it basically just goes and like starts tearing apart the DOM, building sort of its own representation of the DOM in memory. But it's sort of like a much dumber type system compared to React, which can be extremely efficient because it doesn't have to do that. Like it's able to have that full representation of the DOM strictly through what you pass through JavaScript variables. So it really treats the DOM as a remote rendering engine rather than a place to learn from and query. I would say that the only real downside of this is you would then need to, it's important to just keep in mind that you need a larger HTML payload in order to accomplish this, because in addition to sending down your full HTML markup, you also need to send down all of your templates that went into generating that, which can be async through standard JavaScript files, but you also need to send down all of the data that is needed to create that. So essentially your HTML payload could be like doubled. I think that's important to keep in mind, especially for like mobile applications, etc. However, I think it sounds pretty perfect, and this whole concept of the smart server-side rendering like really sold me. I loved it, and so I started, using it. I like went into, at where I work, I went in with this. I tried to like do this massive pitch in order to get us to jump on the React bandwagon. And then we started like looking a little bit more closely at sort of like the actual performance ramifications of server-side rendering. And unfortunately, it just turned out that it's not that great right now. And so also in that repository that I linked to, I have a few different example repositories where you could run some like basic benchmarking. And but essentially the React way of doing things, sort of like the easy way, like they encourage sort of using this Node.jsx in order to be able to like transparently use JSX on the server and render. It's nice. It sounds great. And then so doing all of that the easy way. Here, let me just show you the example, the demo really quick. So for this demo app, I basically got a full megabyte of JSON, generated JSON, and then I render out basically 1,000 items. And there's several components in there, but it's not super complex. I think you can, 1,000 might be a little overkill, but you can probably imagine a page that's edging towards this complexity. And so I think it's important to look at, a complex page. And so I threw a megabyte of JSON into it, and I generated, a thousand lists. And essentially rendering that with Node on the server using React, the time was over a second to render that out, 1,250 milliseconds. Following a few like React best practices, which I'll get into in yep. That would be time to first byte. Yeah. So yeah, that's just the server response. Yeah. Then using the React best practices, which I'll get into in a minute, I was able to get that down to 650 milliseconds. But then using creating the same exact like HTML structure using Mustache, rendering from Node itself, I was able to get that to 450 milliseconds. But then, just as a point of comparison, like rendering that with Go, with a Mustache rendering engine, I was able to get that to 30 milliseconds. So you can see that React, like rendering React on the server, it's kind of a conscious choice that it's going to be significantly slower than other rendering options. And because you could imagine that with Go, you like, which is obviously going to be a lot faster than Node, but just to point out, like you could have a shared templating system using Mustache and then be able to have sort of this isomorphic structure using Backbone or something on the client. So I think it's just very important to keep in mind that React server-side rendering isn't perfect. I still love React, and I think we need to like improve it, but it's better to at least be aware of things than to like be ignorant to it. So there was a pretty interesting talk at React conference where some of the team members answered some questions on server-side rendering, and they basically admitted that React server-side rendering wasn't really like one of their primary concerns. I really recommend checking out that talk. I have it linked to here, and they also offer some suggestions for things that they could do to improve it. Where they say they could do a little bit more with like auto binding and ignoring state, basically things that don't really need to happen on the server that currently are, so that React's core could improve their overall times. So yeah, but basically server-side rendering for Facebook is a secondary concern. Their primary concerns are the client and architecture and client performance, and server-side rendering was really more of a bonus because of like the great architecture that they were able to have in place. Facebook doesn't use server-side rendering in production, to my knowledge. I think that's changing with their update, with their like in progress new mobile application. So I guess we'll see. But Instagram did use React in production, and then they abandoned it. And I think one of the main reasons they abandoned it was because they're a Python shop, and I think they just didn't really want to mess with server-side rendering. So point being, like, server-side rendering is way less battle-tested than React is as a client-side library. However, I think that server-side rendering is definitely one of like the big selling points for Facebook. It was one of the main reasons why I got to be very interested in React, and one of the reasons why I decided to switch onto it. And I think it's also becoming more important as like more companies are starting to use React. Like Netflix is switching everything to React. Facebook Mobile is rumored to be having an isomorphic React application using Relay and GraphQL. I think it would be interesting to sort of think what like other applications that are traditionally not single-page apps that really where server-side rendering is a primary concern. It would be interesting to see like what those applications could look like once server-side rendering with React is like a viable solution for them. So like for example, like an e-commerce site where server-side rendering is crucial, right? And the page being able to work without JavaScript is crucial. So there are applications where server-side rendering is very important that could also benefit from React. Also, like the BBC Mobile just announced that they're apparently switching to isomorphic React, and that's like a content-heavy site. And Flipboard is using React, and so I think over time, like more and more sites are going to start to use React, and I think more and more sites are going to like have to sort of look to answer some of these performance concerns. Because I mean, in my opinion, like once like the performance thing is answered, then I don't really see a downside to React like at all. I think it's a great library to work with. I love it, and I just wish it was a little bit faster. So for best practices, one of my biggest issues is I sort of felt that some of these best practices were a little bit hard to come by. I don't think they're extremely well documented when using React, and you have to kind of like, I have a link here which links to a GitHub issue that I think was last updated about a year ago. So in order to get like the best performance with React, I tried using PHP, like my work or PHP shop, and so I looked at using like V8.js, which is just like a PHP implementation of like the V8 engine. Super buggy, didn't have a great workflow. I would honestly suggest to if you're going to like, if you're really looking seriously at using server-side rendering with React, you should just go with Node. It has much more support, and I think using something like Ruby, Eraser, or V8.js, you're just going to like run into more problems than it's worth. So using Node.jsx, which is definitely, I think, like a no-no in production. Pete Hunt suggested in this in one of the comments on GitHub that eventually it would be nice if there was sort of like a Webpack build step for React, and I think that one of those things that it would do is it would like compile all of your JSX. So in my demo application that I have here, it goes from, it's pretty small, but it goes from 1250 milliseconds to 1240 milliseconds just by pre-compiling the JSX. But that would be a lot higher if I had more components, because I render out a list of 1,000, and as soon as that happens once, it gets cached. So if I had like 500, 100 different components rather than just a list, that number would be higher. One of the big ones is running Node in production mode. So if you run Node and production, it drops the time by about 300 milliseconds. And then one of the very bizarre ones that I think React should really work on is having to wrap React. So not being able to call React directly from the like npm module of like require React. And so if you look at the fifth like React SSR prod in GitHub, you can sort of see what I mean by that. So if you go under source and then lib React here. So basically, if I'm running in production mode, I require React, like the compiled version of React from the distribution directory, and just by doing that, it lowers the time by another 300 milliseconds. So having to do all of those steps, I think like drops the time that it takes to render the application by nearly half, by almost a half of a second. And I think that should like be front and center, in some Facebook documentation, because that's essentially like necessary in order to like for React to be a viable option. Some other things that are really important to do. You should definitely take advantage of like cluster.fork in terms of like splitting out your node processes in order to like for load balancing. I didn't really show what the improvement of the time here, but if you're handling concurrency, that's there's really no reason not to try to take care of better concurrency options. And then the last one is, so like I tweeted out to David Nolan trying to get him to create a closure version of React, thinking that it would be faster. And his response was that basically that people have lived with mediocre server-side rendering because caching works. But like, sure. I mean, if caching works for your application, lucky you. But like, it doesn't work for every application, and I don't really think that's like a viable, compared to like being able to not have to use cache and Go and be able to render out the same application in 30 milliseconds versus like 30 milliseconds here by caching your entire HTML. I don't really see that as like a true option, but if you can cache, you should definitely think about it. So I want to also just touch on a few like crazy ideas that I had, and because I really wanted to make React work, and so I think there's some limitations of Node currently, and I think like Node, it can be a little slow, and I think there's one of like the things that is great, whether you like Mustache or not. One of the great things about Mustache is that it's extremely portable and it's implemented in like every language. If you go to Mustache, their website, you can find a implementation in PHP, C++, Go, whatever. And so you're basically able to render out, regardless of like what your server is in, you're able to take advantage of like shared templates and then use them on the client. Because React is in JavaScript, you don't have that same capability. So like one thing that I attempted to do was I created JSX Stash, which is essentially, I do not use this. It's like it's a terrible idea, but basically it's a custom syntax that I wrote that compiles into both vanilla Mustache and into React on the client. So basically, you'd be able to run a React application in any backend language, and then be able to also pick that up on the client and keep a isomorphic build flow. I definitely wouldn't use this myself, but I thought it was an interesting experiment that I did. And then I think what would be really interesting is if like there were a few like compile the JS options. Maybe like hack or with HHVM. If Facebook decided they wanted to server render everything, but they felt that Node was too slow, it'd be interesting to see sort of like from them, what it would look like if they had like a compile to React type thing. And same with Clojure, Clojure script. So the last thing I wanted to touch on is just sort of this concept of perceived performance. I think one of the things that when I was trying to like figure out the performance stuff with React when it just wasn't working, I reached out to like a lot of people and try to get some feedback. And one of the persons I reached out to was like Spike Brem at Airbnb, and he said that like really one of the main benefits of like server-side rendering is this concept of perceived performance. That it's not necessarily faster, but it feels faster because it renders out. And you don't have to wait for your client to take over. I think the concept of perceived performance is great. It's a great UX concept. When you look at preview templates on Facebook, having that there and then filling it in with content after the fact definitely it reduces sort of like the feeling that the page is jumping around, and it makes the page feel like it's loading faster. Optimistic updates are great. So like when you press save on something, it's nice to like assume that it works. Those are great UX practices. But with regards to like first paint, like I don't think a great option in regards to like server-side rendering. To me, it seems like a cop-out. Saying that the point of server-side rendering is perceived performance, I just don't think is it doesn't give enough of the. There's a lot more benefits to server-side rendering other than just sort of making it feel like it loads faster. For a lot of sites, like being able to have the page function without JavaScript is really important. And then also for SEO, of course. But so I guess I would say I think we should stop using the phrase perceived performance, when talking about server-side rendering. I don't think that that's a viable option. And but should you still use it? I would still say yes, because React is awesome, and I think that as a sort of React community, we should be trying to sort of figure out how to make server-side rendering faster, because I really do believe that once that's figured out, and rendering with Node is the fastest option, then there's really not a lot of arguments against using React. So yeah, that is it. Yep.
I can see how even if SSR works really well, how React
Sure. Yeah, I mean, it's just if you follow semantic HTML and you render out with, React on the server, and you generate, say, for example, you render out a form, and you have an endpoint on your server that responds to that form. You don't need any. Yeah, of course, but I would. Well.
So the advantage is also not. That is basically that just decompose as rendering methods. There's no one to.
Definitely. You would always want React on the client if somebody has the capability of having JavaScript. But every application is different. Some applications don't care about users that don't have JavaScript enabled. That's fine. I think if you're looking at sort of what the perfect website is, I think that the perfect website is one that works both with JavaScript enabled, JavaScript disabled, renders fast in the server, client picks up to provide interactivity. I think when we're trying to come up with sort of the concept of what is perfect, I don't think we can just sort of always assume that JavaScript is going to be on a client. If you were responsible for a major e-commerce site, for example, you would want users to be able to complete checkout without relying on JavaScript. So if you're able to have your a form that renders semantically on the server using React, if somebody has React on the client, then sure, that's great. Intercept the on submit. But if they don't, allow them to submit the form to the endpoint and work just like a standard HTML application. So I think being able to have both is really important. Yep.
Just one is in user C components. It actually is really important. I mean,
yep.
Consumer facing app. And besides SEO stuff like that, there's a lot of studies who can see actually just our own metrics. And even smaller tiers see just think of yourself when you search it around the links, how much things relates to the path,
I didn't mean to downplay perceived performance. I just sort of meant that it should just be performance. I think of course perceived performance is great and very important, and anything we can do to improve the perception of how performance works, and that's great. I just think that in terms of delivering an actually fast experience, performance first, perceived performance is a backup, and but yeah, I didn't mean to downplay perceived performance. I definitely think that that's important and a great UX strategy across the board. Yep.
So, I don't know so I was wondering if you had any ideas why this one's for.
Yeah.
I guess correspondingly, why do you think JS is sick? Or do you just think it's not?
Yeah. Okay. So first, in terms of why React is slow. Okay. Well, one, I think that those best practices should really be more front and center. And I think there's, so like, let's assume that the baseline here is like 650 milliseconds, like ignoring the not best practices. I think from there, in order to get to like where the mustache version is at 450, I think that should be like probably, you know, the goal. You know, that to me seems sort of like the baseline of like where Node's capabilities are maybe. And I think then those are sort of more of the going back to like what the Facebook engineers touched on at ReactConf. That is sort of more like getting rid of worrying about state on the server, getting rid of optimizing the React framework itself in order to render as fast as it possibly can. Right, right. And so like, I don't know like where the true like best number is. You know, I would hope that it's lower than 450 milliseconds for this. I would hope that it's like, you know, 35 milliseconds. But I guess we're sort of at the discretion of there really only being like one JavaScript like runtime solution right now, and like only having Node as an option. It would be very interesting to sort of see other JS solutions other than Node. And then I also think it would be very interesting to sort of see, like I was mentioning with the compile to JS languages, you know, because if Clojure, for example, like if they rewrote React in Clojure and that just like worked, and then you're using like OM as a way of writing your client-side applications anyway, and it didn't rely on V8 and a JavaScript runtime, you know, potentially this could be way faster, but like can't really know until that happens. But I would really hope that the baseline number is definitely a lot lower than 450 milliseconds, but I guess like right now I don't know for sure. And in terms of why JSX Dash isn't the solution, I mean, I think right now like the React community pretty much hates Mustache, I think, and you know, that's one of the big, you know, that's one of like Pete Hunt's big like critiques of Mustache is like that, you know, separation of concerns versus technologies, and also like there's a ton of benefit of like writing in JS and having access to actual JS functions in JSX, and writing in, you know, I wrote a few example applications in JSX Dash. You can check out the GitHub if you like, but it's more it feels a little bit more like writing traditional Mustache applications versus writing in JavaScript. But there's definitely, again, there is a benefit of the portability, because like I was able to render in, you know, PHP with a C++ Mustache extension, and then you know, and then have it compile into that, and then also into React in the client, and have it hook in really nicely. It's just when you're thinking like there's a lot of holes in that, and I think for that to be like a real solution, there would need to be like a much more of a community effort behind it, and a little bit more official support, I guess. So yeah.
We don't know because we haven't profiled this, but I think the thing you're actually trying to talk about is trying to execute JavaScript on faster execution. It's not about Clojure. You want to run it on JVM, so V8. But you could try it possibly as there's NASCAR.
Yeah, no, that's more like VHJS and like Ruby Racer. So those are like V8 engines, and like Nashorn is true slow. I've read reports about. And I'm actually talking about like rewriting React in Clojure and not writing any of your React code in JavaScript, writing it all in Clojure and ClojureScript. That's what I mean, as a way of compiling to JavaScript and not having a V8 runtime at all. I'm just thinking of that as being a potential interesting experiment. But yes, like you can. Well, it could be implemented in any language, theoretically.
Okay, and then you just don't care about
You can compile that.
It's just like a, you know, a crazy type of thought, but like it'd be interesting, I think. Any other questions? Is anybody? Yeah.
Just one comment. I just found a library that does Go server-side rendering called ReactJS. So
Interesting.
try
But
that out, I guess.
I will try that out. I love Go, by the way.
Benchmark is 39 milliseconds. So.
All right, I'll check that out. Does anybody use React server-side rendering in production currently? I'm really curious. I wish there were more people that use it because like it's just kind of a struggle to like. I tried to make this fast for as long as I tried really hard to like make this a viable solution and to make it as highly performant as possible, and it's tough to find things, and I hope it improves. So, yep.
Thanks, Nick.
I guess we'll take about a 10-minute break, and we'll have our next speaker speaking about.
And then I'm going to scroll. I really shouldn't blast this out.
Well, I think you want your overall desktop, right? That's your entire screen. Yeah, I guess it's not great to blast out. Okay, the way you've got it set up, I guess you won't.
just do this. I'm in the Hangout.
All right.
Cool.
Awesome.
Yeah, they're
Exactly.
What's that?
I'm just asking if you guys are PHP guys. That was the I wasn't around when that happened. Microsoft, like, so they're
We haven't had it for 3 years. From scratch. How to make it complex library is only coming up as already have potentially wide functioning
yeah.
Most enterprise access to go this direction is like, yeah, you guys go first. There is more work you don't have to do. Static sector, yes,
Oh, right.
Got it. Exactly.
as much as I want to get that done, it also means that I have to tear apart. I'm happy to tear apart, but I just don't think I want to do it.
All of us compilers. Or just like launch and it's like
I didn't see the first reference.
Yeah.
Oh, you get a phone.
I got hat.
No, it's the best screen of all.
It's gender neutral.
Yeah, it is.
They're very special. Very good.
Ever since 2007. I'm gonna use that. No, you're
Also,
like
at the contact
Oh, that's on the team. I had some.
Okay.
So, wait.
You need to share your
Oh my God,
See
computers.
it so that they can see your face.
That's nobody wants that. Okay. Start.
The green button top left.
You're right.
Am I?
Yeah.
That means it's working, right? The cursive. All right, cool. Okay. So I should be louder.
Yes.
Excellent. Okay.
Slowly.
I speak really fast, so if anybody wants to interrupt me, you're allowed to. I completely speak too quiet, you're allowed to tell me to be louder. This is probably going to run long because I didn't actually get to run through the whole thing. It's kind of winging it. So if anybody gets bored, feel free to leave. I will not be offended. What I wanted to talk about was building a Flex library. When I submitted this to Jeff's thing, it was like months ago, and Facebook hadn't even released the Flex repository that they have now. So like they'd like discussed it, and it was this idea, and then there was no code. So I worked with a couple people and built a really quick implementation of it. Since then, louder? Okay. Since then, it's Flex is sort of wildly popular. There's something like 25 Flex libraries that I've seen on the internet. They all take slightly different takes on it, and that's one of the interesting things about it. But I'm going to go through the really basics, the really basic parts of getting Flex working. So like the code that I'm going to show you is not impressive at all. It's meant to show you like the most basic example of the concept. There's only like 1 or 2 sticky bits in Flex. So let's see what I got here. This is a fancy quote that I like. I'll bring it back later. If you guys don't know this quote, it's cool. Can you read that? Okay, hold on. Let me make sure. Okay, cool. That's the accessibility thing. Okay. So that's me. That's my Twitter handle. I work at a fashion project. I have a side project called Water Cooler. It's like it's a chat app. It's like Slack, but it's got its own flavor. And then the group that I work on Water Cooler with tweets at structuralists. So why would you want to build? So real quick, there's people new to React. Who's written a line of code, a line of React code that's in production? All right. Who's looked at React code and like tried to understand it? All right, cool. Who's written a line of Flex code? All right, getting there. Who's running Flex in production? Nobody. Okay. So my warning doesn't matter. Okay, so think about this. I'll get to that. Okay, yeah. So the Flex provides like the Facebook has said that React is the V in your MVC. And so if you want to use backbone models and just render out to React, that totally works. Speak up. Okay. I will keep speaking louder until you guys tell me not to. So Flex is the V, React is the V in your MVC. You can use whatever data model you want. You can use any existing models. And as long as your views can subscribe to that data, they can render it out, and it should all just work fine. But Facebook sort of created this pattern, they call it a pattern, for Flex, that is a way to deal with data just very simply, actually. The goal is to treat your data as just data. It's not models. It's not designed to work the way MVC works, and it's designed to sort of like get your data, stick it somewhere, and then render it back out. So when the tricky bit in here is a concept called wait for. And so I wanted to sort of understand, they released the implementation of it. I didn't understand it for a long time, so I sort of dug into it. I'll run through exactly what wait for does. It's the only tricky bit, and it's not that complicated. And so the other thing is that because Flex is so simple, you can actually understand the whole thing. You could not have a talk called Ember.js from scratch. It would be 45 hours long. To set the tone for the amount of professionalism you're going to see in this talk, I was doing a Google search for funny images from scratch. This is what you get. It's kind of a smattering. Bottom right was this one, which I thought was wonderful. So there you go. Just setting the tone. All right. So audience-wise, if you're totally new to React, just kind of try to just follow along. It sort of hinges on understanding the basic premise of React, so I'll try to sort of review the really important bits when we get there. There are no Flex pros here, so don't worry. All right, so a quick review of React. Has everybody read something about the virtual DOM? It's like a fancy implementation deal, and it turns out it actually doesn't matter. It's just cool. All the tree differing stuff. The thing that React super gives you is that you get to break your app into little components, and those components compose well. That's like a huge premise of a huge premise of React is that your components compose easily. And when you have some high-level component calling a low-level component, it's just calling a function that is returning a representation of what you want to see. Like it's returning a React element, which is just a representation of what you want the DOM to be, and some other component's going to call that component, and it's going to return up that representation, which includes the previous one. It's going all the way up to the root, when you're going to call render, and it's going to shove that into the DOM. So the other thing that React does is that most of your application is going to become a function. It's just going to be your DOM is a function of state, and the two important methods are get initial state and set state. Those make dealing with state really explicit. So the state, if you want to trace the state of your component, it either came in through a get initial state or you called set state at some point. Other than that, there's no other way for state to get into a component, which means that like tracing bugs is a lot easier because you can sort of trace those two functions. Those are the only two ways to get it that anything happened. So the stages of getting to Flex. A lot of simple apps can just use React as is. You can just make a network call, load a bunch of state, call a bunch of components underneath you, and render will just work. When you get to a larger amount of data complexity, you want to put it somewhere, and so you create stage one comes from a really decent blog post by, does anybody know Ryan Florence? The name on Twitter, that kind of thing. He wrote half React Router. He's a cool guy. So he has this thing about using a sort of single store. It doesn't do some of the other stuff that Flex does, but it gets you a place to put your data and deal with stuff. As your app gets bigger, you want to deal with multiple stores, and you need to deal with dependencies across them, and that's what the Flex library that Facebook put out does. And at some point, now there's 25 libraries that all implement Flex. So in vanilla React, if you have a high-level component that calls a list or something like that, and you want to change the state of that component based on a child, the thing that the React docs tell you to do is pass the data down as props and pass callbacks down, and have the low-level components on like a click event call that callback, and it'll set the state on the parent component. Has anybody who's read that page in the docs? All right, at least half of you. All right, so you end up with sort of this tree. You guys read the light green? Yeah? Yeah. Oh. All right, so there we go. Okay, so you pass down data, all right, and you pass down a handler function, and then you bind on-click on the bottom div. When you fire it, the top component will call set state, or something will happen, and then the whole tree will re-render. And they're like, ta-da! You can make applications this way. But the problem with this is that it gets really fragile because your intermediate components have to pass all this stuff down. So the middle components know about the handlers even though they don't need to. And if you want to go move stuff around, you've got to reset this tree. You've got to like pass the handler over here now, pass this over here. So this gets real old real fast. And as your app gets bigger, say you have like a tree, some kind of app has a tree on the left. It's super common to have like a file tree or something. If your nav wants to interact with that in any way, sort of be aware of it, then you've got to put all your state above both of them in your DOM hierarchy, because everything's got to get passed down through props. So you end up like shoving all your state really high up, passing it all the way down through all your components, and then the whole thing's just really fragile. Does that make sense? All right. Oh god. All right. So what if you want to pass your, if you want to sort of move information laterally through components? Yeah, and so to summarize that, if you think of your app as a representation as a function of your state, then you want to separate sort of data. This is sort of the goal of MVC at the same time. Separate the dealing with data with the presentation of the data. So Keep going. Okay. You can't get away from mutable state because that's how applications work. So the question is, what do you do about it? Because this is where all your bugs come from, but what do you do about it? And so, also a good quote. Any other quote? This is what Flux does. It says, pull all your state out of your components and just shove it somewhere else. So the simplest idea of Flux is the top view, instead of holding the state itself, stores a copy of the state, which is stored in some kind of external object. And your low-level component is just going to call a method on that store that's going to deal with whatever is going to happen, or whatever you want to do with your state. In this way, something way above that top view can call the same method. Everything that has access to this can call the setter method. And so this separates those two concerns of like data management and data presentation. All right, so Flux's implementation, I think, used event emitter. This is when I was trying to make the food analogy still work. So stores emit a change event and then run callbacks for all the subscribing views. And so the event emitter gives you a whole bunch of powerful stuff. You can do coalescing events and lots of named events and all kinds of stuff. You need one event and you need to run some callbacks. So, question? Or?
So with this, with this data into the store, these callbacks that register on the application, use on the application, plus set state.
Yes, that is exactly correct. Yeah. So that ends up with a lot of boilerplate, and then there's ways to get minimize that boilerplate. So change events. This is I have some stuff that's just code, and I don't know how this is going to go over, but it's just really short. Okay, this is what it takes to get registration to store events up and running. Is literally just you need a register and an unregister function. The store needs to do the trigger, which is just going to run the callbacks that you store. That's all it is. Conveniently, React methods will be auto-bound to their context. I don't know if you guys have run into, there's a crazy error message when you try to bind a React function. It's like, hey, don't do that, we already got it, buddy. So you just pass in that callback, it will just be run correctly, you're good to go. So this change events. What you're going to do is you're going to call register on component mount, and you're going to call unregister on component will unmount. And that makes sure, has anybody ever used is mounted? This dot is mounted. It usually means you're doing something wrong. If you don't, say your unregistered didn't work, you'll run this callback against an unmounted component, and its context won't exist anymore. So you just need to make sure that these registrations are only present when they should be, and then go away. All right. So yeah, the ideological thing. What this lets you do is pull all your state, all the state of your application is into your store, and then the only state that might still be in your components is something transient. So if you're dealing with animations, you might be computing a whole bunch of crazy stuff, like moving something across the screen. If you're just going to throw it away, leave it in the components. Don't worry about it. It doesn't really matter your application. All right. Am I going too slow? Am I going too fast? Is everybody following this so far? What's that? Where? Okay. So the question is, stores are conceived of as this place to put information that all relates to some logical part of your app. So you might put a collection of something in there. You might put a bunch of random UI state facts. You can put anything in there that's just an object of method in the end. And so as your app gets bigger, you want to break up the application into logical parts so that working on one part doesn't muck with anything else. Did anybody watch the React.js Conf talk where they taught a Flux panel? So at some point, some of the guys from Facebook were like, oh yeah, our app's got 95 stores, and somebody else was like, our app only has 65 stores. So you just boot one up for whatever you need, whenever you need to hold some part of your data. So the question, if you're implementing this, you can have two stores, and now if you go to call set on this store, if they share any sort of, if they sort of have any dependencies in state, if there's just if they store A and B need to talk to each other at all, calling set on store B means that store A doesn't know that that's a change occurred necessarily. So one way to solve this is like for store A to subscribe to events on store B, which would be like a very backbone or evented system, or like there's a whole bunch of systems that work that way, where just some object is going to respond to events on some other object. That's totally another way to solve this problem. I bet some mathematician could prove that it's sort of isomorphic with this problem, the way that Flex decides to solve it, but they deliberately eschew cascading updates. They don't want a change on one thing to continue propagating down with additional change events. So the first thing you do is you invent this concept. It's a made-up thing. You call it an action. An action is a globally available thing that says, I would like to change the state of the system. Okay, and the best way to write them is to keep them idempotent. Okay, the best ones are analogous to HTTP put. They're a statement of fact of like, this is the new data for this thing. And so if you call if you call the same action 5 times, you would just end up with the same state at the end of it. Toggle is like one of the most insidious words. If everybody's written jQuery, toggle class, okay, is like super common. It means you are storing state in the DOM. Like you have to be, because you're asking the DOM what the state is and then asking you to change it to the other thing. So like you're storing information there. So if you have an action that's like toggle this thing, it's less predictable than set true and set false. So anyways, the question is now, what do we do if some little fact in store A, store B depends on that thing? You have some list, and one of them is selected in store A, and store B is the details of the selected item, something like that. So store B needs to know something about store A. All right. So not sure I want to show this, but whatever. All right. It's like I'm missing a diagram. But what's that? Yeah. All right. This is where I should have like finished reviewing all this stuff. Everybody following along so far? Are there any questions on like what's going on?
Yeah, I have a question if you have like 2 different views updating one store. So let's say you have a view, you click on something, it creates an action to put something in the store, which ultimately makes another view render. Does that make sense?
Mm-hmm.
And then you like navigate away from that first view. You fire another action to like unset the state in the store to unrender the other view?
No. React will just respond to whatever the state is. So you never need to unrender anything.
Right, but should you fire an action to like unset state in the store? Is that the right pattern?
No,
Okay.
I don't think so. Or the goal should not be to. So like
if I have a list of things in store,
mm-hmm.
it's like not a good pattern to fire an action to like set that list to an empty list.
No, that's a perfectly valid thing to do. One thing that you do a lot of times is that you try to cache things in stores rather than setting. So like if you have a collection, or if you have you can have a store that holds an item, and then when you navigate somewhere else, like an AJAX request goes and it stores another item, and it replaced the previous item. But it's much more flexy to store like a hash of all the items by ID, okay, and then store the active ID. Okay, and so then the view is just going to get the right item for that ID, and when you navigate somewhere, it just resets the item, the active item ID, and the cache stays the same. So the cache is idempotent because you just put into it, right? And then the only thing you're mutating is that active ID, and you set that to null, and then you move on to life, and the view just says nothing's selected.
So one thing I'm unclear on, so is if we talk about what happens when, so store A is talking to store B somehow,
Mm-hmm.
but the action has to be processed by store A, and the action has to be processed by store B. So we talked about again about how we ensure that store A processes the action, then communicates to store B, then processes the action.
Yes.
Because that's different than the store B processes the action. It doesn't know the thing it needs to know from store A. Now, of course, if things are pure functions, that doesn't matter because store B.
So that's exactly the point. I didn't include a slide.
Okay.
So excellent question. The way that actions work, I guess, so I left off something that Facebook usually puts in there, which is that if you heard of the dispatcher. Let me zip ahead real quick to, okay. So the dispatcher is this object. Your framework should eventually be abstracted away. You shouldn't need to know it's there. But it's there for the purpose of multiplexing an action. So an action is a statement about the fact that it's a statement about the fact that I want to change the state of my application. You send it to the dispatcher. The dispatcher will send it to all the stores. And the thing that Flux does, instead of having stores that subscribe to change events on other stores, it ensures that the stores will resolve in a certain order. Okay. So if store A is going to call a getter out of store B and store C, then the dispatcher will ensure that it is only run after store B and C resolve. Okay. So the thing that I sort of have at the end of the talk that I'm going to jump to now is that the idea is that an action is a request to initiate state change. The dispatcher will figure out how to change all these stores in the right order. And then your views are all going to update, and then the function closes. Like all of that change happens within one. It's actually the entire call stack comes from the callback that you bound to the click event or whatever it was, right? So like in your view somewhere you click event. That click event calls an action. Action's going to call in the dispatcher. Dispatcher's going to call in the stores. The views are going to call set state, and then the function's going to close.
The wait store bit is the target grid, so the dispatcher knows, hey, store is waiting for me to process this action first.
Yeah, so
So I'm a little clear, because I've never implemented
so you basically call dispatcher.wait. Inside of an action callback, you call dispatcher.waitFor, and then you hand it like an identifier for a store. And
so that's sort of happening. So
yes. I will discuss runtime versus like sort of initialization time dependency graphs in a second.
All right, I'll just stop asking questions.
These are good questions, don't worry.
Motivate why we need multiple stores. Is it not enough to have a single store and namespace for keys or something? Like, what's a good motivation?
Mostly, it's like working with other people on a large application. If your entire app could be global app state render, and that massive object is like tractable for you, then go for it. You're done. That's Ohm. If anybody's you see anything about Ohm, Ohm's entire premise is that there is this one object that is your global app state, and then it renders it. And then whenever any event occurs, you just mutate the global app state and re-render. And it's a sort of ideologically pure premise, but practically it kind of gets difficult to deal with. All right, so. Oh my god. Okay, so I'm not sure how this is going to go. They need more code or less code, I'm not sure. So, we're just going to try it. So this is my attempt to sort of represent what's going on inside of the dispatcher. Okay, so some action comes through. We've got 3 stores, store 1, 2, and 3. All right. Store 1 runs function 1, store 2 runs function 2, and store 3 runs function 3 when that action is called. So the dispatcher holds an object somewhere in the dispatcher. This object is present. Okay, so it's keyed by which one needs to run. But it's an object. It's not ordered. It just knows that these 3 callbacks need to be run. It knows the function, and it's going to keep a little bit of information about the state of that callback. All right, and so this is sort of Facebook's way for sliced up until you can read it top to bottom. The dispatch is, you start dispatching, you're going to run all the callbacks, you set it fresh, and you're going to run all the callbacks. And the key is that while you're running that callback, if anybody calls wait for, if something's still fresh, you're going to run that callback and then return. Okay. So then when we finish iterating through the callbacks, all the ones that needed to run previously will have been run. If that's just like blowing over your heads, don't worry about it. This is the entire code. This is all of Facebook's dispatcher. Like this is all it really does. Is for a given like unordered set of callbacks, make sure they execute in the right order. So this is the point. Is it's actually pretty random. So it's whatever. It's you're just going to start iterating through those. And so that's the whole point. Is that if you have 3 stores with no dependencies, they can resolve in any order. If you have dependencies, wait for will just ensure. Oh, I have a dependency. Run that one first. Okay, come back now. Finish running me. That's all it does. And so that gives you. So that gives you a runtime assurance. There's a check that if you've gotten yourself into a circular loop, it throws an error. So it gives you a runtime assurance that you have no circular dependencies. The problem is if you write this code, and somewhere you will write this code, there's a bug in here. Sorry, what?
The code on the previous slide. Could it say everything was over fresh?
So what will happen here is you'll start running the callback for B. It'll tell you run the callback for A. Sometimes A will say please run B, but you've already tried to run B, so you'll throw an error saying I can't. You either throw or you blow your call stack. No, I think I skipped that. Yeah. So if you have a circular dependency, Facebook's dispatcher will see that you're running you've got a pending status on the one that you've come back to, in which case you already were there, in which case you have a circular dependency, and it throws. What?
How you declare the dependencies?
Oh, sorry. Yeah. So when you register in Facebook's dispatcher, it assigns an ID property to the store, and so you just say, I want to wait on that ID.
You only encounter the dependency once you're actually running the callback in Facebook's dispatcher, because it actually goes through and executes the wait for. Like, I'm going to wait for this.
All right. So does everybody see the bug in this? Or like how this would be a maddening bug, actually? Because like at some point you're going to have a massive callback, and somewhere buried in it is a conditional and then a wait for, and it'll drive you crazy. So the other thing you can do, Facebook doesn't do this, but you can sort the action callbacks at like the initialization of the application. As long as they declare the dependencies in a slightly different way, you can just sort those callbacks into an array instead of an object, and then just ensure that they're in the right order right then, and be done with it. And then whenever you run that array of callbacks, it'll just execute in that order. It's a little more code, and so Facebook seems to sort of like err on the side of simplicity. Wait for is really simple. It just has that one sort of possible error. All right. All right. All right. So the Facebook released Flux as like a pattern at first. They didn't have any code, and then they released a library that implements the dispatcher, but just the dispatcher. They just sort of say, implement your own stores, do whatever. And they released React as a library. Okay? And so this is an interesting question. React solves a bunch of nitty-gritty problems. Has anybody seen how React handles cursor position when you redraw an input? This is like a really big problem with like naive equivalents of React that do virtual DOM stuff. So like you re-render the whole app, and the cursor position you had on something, scroll position, that kind of stuff, can just get lost. So they do this trickery where right on the event callback, they save something. They let everything happen, and as long as like the set states were called synchronously, they'll just keep the cursor position where it belongs, and it all just works out. So that's just like a really nitty-gritty thing that nobody wants to deal with, and React just solves it out of the box. You literally never needed to deal with it, is the thing. All the virtual DOM stuff is actually computer science. It's actually hard. Yeah, and then synthetic events. If anybody's done programming with non-synthetic events, they're miserable. And synthetic events are still miserable sometimes, but a lot simpler. And so Flux doesn't solve like these nitty-gritty problems. It solves this sort of like, it's just a way to think about your code. So, if MVC is sort of this pattern around how you structure where you're going to put data and what functions are going to run on that data, then Flux is a different way to organize data and where you're going to put functions that operate on that data. And it implies some constraints that are sort of not typical. All right, so I didn't explain this well, but I'm going to roll with it. Actions are designed to be the only way that state change happens in your system. So you define a whole bunch of actions, and all your event handlers call them, and they all send new information into your system. And there's no other way that your application can have its state changed. That's the goal. So what I realized would have helped is a demo. All right. So we don't use React much at work, but we have it on a couple of our complex forms. So if I go good. Thank you. All right. All right. Is this sort of viewable? All right. So this is a form that like gave us a whole lot of trouble before because it has like a lot of inline validation. It gets customized by a bunch of Bootstrap data that gets passed in. So I think my Redis server might not be running, in which case this might not work. Cool. Okay. So you can pick one of those things, standard address form. And so these have like, this is all just React being React. Like inline validation pops up. This is just, so there's like an input component and knows how to like take a validation function. If that fails, it throws a message that says stuff. All right. All right. So this is totally just React is fancy. Okay.
More dumb questions.
Yeah.
Is there like a EF handler that's changing state?
Yeah. So, what you normally do is you call set state on the event on the change handler. You call set state on whatever's driving that input field. That would be the sort of idiomatic React way to do it. What it's doing right now is it's calling an action that says update this field, and then the Flux store is being updated, and then the change event is firing, and then this view is subscribing to that and pulling that new field down, and all that closes synchronously. So the cursor position stuff just works. So let me, all right. Can I like do, maybe, kind of? Oh, Flux, okay. Ironically named Flux, okay. Does everybody know about this Flux? All right, let's see if this works. Okay, so let's do this real quick. Here's what we're going to do. I'm going to improvise a little bit. Okay. All right. This is the Flux library that we use at work. It's a Frankenstein monster, but it's 275 lines of CoffeeScript. Like it's not unmanageable at all. What I'm going to do is I'm going to find this on action, send action. All right, here we go. Totally forgot to talk about payloads. All right. So what this is going to do is every time an action is fired for the entire application. We're going to log the name of the action, which is just like a privileged string that names it, and then the payload that was passed in, the data that it's presented. All right? So watch Rails recompile really slowly. All right, cool. So, what's up? Yeah. Okay, so that console.log bootstrap.js is just because I'm in debug mode, but then these are just these are 7 actions were fired on like initialization of the app. Okay, but what's happening right there is right here. We just grab bootstrap data out of the HTML, and then for the keys, for these keys that we find in the bootstrap data, fire this action with that data, whatever's on that key. All right. So like this is the last JavaScript loaded by the whole application. So these are all shoved in by Rails. We just fire these actions, and that sort of like initializes the state it stores. All right. So those are right here. States, charity info. This is all just stuff that was handed over the wire. What's going to happen now is that every time I type, okay, the update form action is being fired, and it's being passed an object with these 2 keys. All right, and so some store is subscribing to that and figuring out what it wants to do with it. Think about what's this is a bad one. This is toggle. It's a bad one. It's toggle. Shouldn't do that. So yeah, so the point is that the thing that you get by only setting the state of your application by one method is you can trace that method. Okay, so this is the history of the state change of this entire application so far, right? Like this is the transcript of everything that's happened in a really straightforward way. So the other thing you do is you can inspect the current state pretty easily. It's just data. Okay, so. All Flux and Elm are actually very similar. They just argue about what things are called. So, yeah, cursors and stores are like cousins. They're not that far apart. So, what I've got in here is, where's my address? Yeah. So this is a store that handles the address information. All right. And so it's got a bunch of getters on it that can get state back out for the views. So like the views can subscribe to this store. They can call these getters to get like the fact that it's ready, some information, but I wrote this, but I don't know what it does. And so what I'm actually going to do is, this is the sort of data that defines it. We've set these 3 fields so far. All right, so the yeah, all right. Does that make any sense? Like, what's going on there? Approaching like too straightforward? I don't know, but that's how you modify the state of your application. The view just re-renders and draws stuff. So actually, okay. So yeah, so actions on the way in, you can trace them, you can follow what's going on. For debugging purposes, this is wonderful. You can literally just put that console.log in and just start using the app and look at what's going on. And you can sort of see where you hit an invalid state. You know exactly what the state change was, what was going to be happening right up until you threw an error, that kind of stuff. It makes debugging pretty straightforward. So yeah, so the other thing that you get out of this is because your state information is just data in the stores, serializing it and deserializing it is really easy. Another thing in the Flux panel was sort of doing some sort of server-side render in using Flux, shipping down the HTML, and then just shipping down some JSON to boot the stores back into the state they were in when the server figured it out, so that you could just pick up where you left off. So does this make sense? If you have some data method that just sort of outputs the object, just make an object. You have your state. Load it is just for every store, load the data. Yeah. So this is where I wanted to get to, but I didn't do a good job of it. So React is like this. The goal of React is this stateless DOM. So DOM is just a function of whatever else is going on, but you don't go and poke the DOM. You don't deal with it. And if you just blew it away and started over, that'd be fine. Flux is the stateless virtual DOM. You store all your state in your stores, and the virtual DOM is just gets information out, renders. So the other thing is that the new state is just a function of the old state and whatever action is passed in. Actions have to close synchronously, and so does anybody know what happens? Like, say you set a network event, and on a callback, you're going to fire an action with like new results. Okay, what happens if a network callback comes back while you're closing the previous function in JavaScript? Sure. Is that a crazy question? So like you're in the middle of executing some kind of string of callbacks from an action, and in the middle of that, a network event comes back and fires another action. What happens? Is JavaScript multi-threaded or single-threaded? What's that? Either one. So, the point is, JavaScript single-threaded. It just pumps things out. It just pumps things out of the event queue. Like this totally leverages that. So if this holds, like the new state is just a function of the old state in the action. This is always going to be true. There's no way for like anything weird to happen in the middle of those callbacks. Like that event handler has to finish. There's no asynchrony. There's no promises. Nothing else is going to happen. Your state is going to transition from the old state to the new state. And if your stores set up their functions correctly, then it has to transition from a valid state to another valid state. So, but what that also gets you is that like any state is just reduced against the history of all the actions. That's like all of your stores becomes just this giant state transition function to go from old state to new state. And so that makes it relatively easy to sort of reason about how you move between your states. So, and then you can add it all at the end to DOM. That's lots of React. So yeah. So the moral of the story, though, is why shouldn't you? Maybe this didn't seem simple, but you can write your own Flux implementation in 200 lines. Why wouldn't you want to use that? There's two big reasons. There's the boilerplate is obnoxious. You take what's a simple component and you make it into a store and a component that calls getters, and you're just constantly passing stuff around. You're like, you just get initial state, you're calling getters. On change events, you're calling getters. It's just the naive Flux is a pain in the butt. Mixins help, but mixins I've had really mixed results with sort of them just having really weird, unexpected behaviors. They're just they work when they work, but it's very easy to a bug in a mixin will kill you. So the other thing is the dependency graph stuff is kind of complicated. Your own dumb bugs will kill you, and this debugging stuff only really works if you can trust the framework. If this is the way you're programming, you better trust that framework to be like bedrock. It's going to work. Okay. So, yeah, a good Flux library will provide constructors for everything. Like Facebook's doesn't do this, but Marty and there's 10 other ones. They all provide constructors. So you just hand an object you hand a definition of a store into a constructor, and you'll just get a bunch of constructors. A lot of them abstract away the dispatcher, and so you just define actions, define stores, they register actions. It all just works in the background. If you've used React enough, you've seen their really good error messages for like couldn't do this thing, because you probably did this wrong. Don't use class name. Like they spit out really useful error messages. A good Flux library will do the same thing. It'll say nobody's listening to that action, buddy. You just tried to call an action that nobody's listening to. Your store is listening to an action that doesn't exist. Whatever else. It'll be tested, and it'll have docs, which your random code will not. So yeah. So my callback to Isaac Newton. Okay. That may have made Flux seem more complicated than it is. But was there any part of that you guys didn't follow? Because that's the whole library. That's all it is. Do stuff in the right order.
Because this feels like promises or something. It's kind of a simple idea. You can use ours
So the thing that Flux gives you versus promise programming is it's
no, I don't mean to
Maybe analogy.
We do have like you said, it's a pattern. It's like libraries.
This is sort of the second talk I would much rather give, is like, how do you evaluate these things? Because a lot of them do the same thing, and they take like, they take sort of like certain opinionated stances on things, and this is one of the cool things about releasing it as a pattern, is that as a pattern, it was like, let 1,000 flowers bloom kind of thing, and now we've got like 25 Flux libraries, and in 5 months we're going to have 25 new Flux libraries, and half of those old ones will be dead, and half of them will be enormous frameworks because of scope creep, and like a whole bunch of crazy stuff's going to happen with it. But there's one that I just found out about called Flux Nexus, which is insane because it does like server-side rendering and then like hands stuff down to the client and like wires up a bunch of WebSockets for you, and it like picks up right where it does a ton of shit. And then there's ones that just like provide some basic instructors. There's one called Reflux that I don't understand because it like doesn't abstract away the dispatcher, it removes the dispatcher, so I don't know how it works. But there's a whole bunch of different variations, and so I wish I had like used. A lot of people have actually been clamoring for Facebook. Can you please release a framework for Flux the way you released a framework, or at least a library for React? But they're just like, no, it's a pattern. Here's some dispatcher code. Take a look at the dispatcher code. It's like 500 lines. It's all comments, and it's 100 lines away. Just wait for it. It's like so simple. So yeah.
If you want to evaluate one, like, I think the best way to go about doing it is like looking over the Facebook dispatcher and like spending like an hour trying to write your own, basically, and then looking over people's like discussions about Flux, and then ending up like choosing Mario. Like,
yeah, try to write your own, then do somebody else's.
Yeah.
One thing is I sort of analogize it in promises, where it's like promises are a simple idea, relatively simple idea, and you could write your own pretty easily, and get lots of other people's that are theirs with various different features. Really interesting topic is was writing about, talking about how you just had this like bit of verbiage with somebody who's understood promises, and writing the promises based on spec these tests that promises should all any promise implementation. I wonder actually if someone should do that. Like, okay, you can like make all extra features involving like server-side rendering and WebSockets into it, but like as these tests and all once.
That's not exactly the same thing they did, but I think that's what they wanted to do. Is they released the part that is at all sort of subtle and complicated. Like the wait for is tricky. The rest of it is just sugar. It's just, is calling a constructor easier than wiring up the whole thing with a ton of boilerplate. The graphic or the code? All right. So yeah. Any more questions? Has anybody shoot?
What are your thoughts on Relay and how it might affect?
Relay is going to make all of Flux obsolete. Like, it just solves the problem in like an automatic way. Like
just the only
it like practically solves the whole thing. So Relay was announced at the ReactConf, and it sort of is a library. It's what everybody wants. It just does it. It solves the caching problem by like running a tiny database locally that stores all the network responses, and it solves sort of like a lot of the verbose action nonsense with syntax for declaring data dependencies in components. So your components declare, I need this data. The components above them like grab that and sort of compose a larger data structure and hand that off to Relay, and Relay goes to the server and just gets all that data and brings it back down. So it sort of is that. It is Flux done where you don't need to do any more work. It just works. That is if like the hype lives up. If Relay actually pans out to be as fancy as it seems. They made React, so I'm gonna go with I'm gonna give them the benefit of the doubt.
But it's not a big one.
It's like a couple months or something that they think it's gonna be out. Alrighty, that's all I got.